Section 6.4, Section 6.4, assessing normality and the normal probability plots. What do we have in this section? What is this section about? So the random variable x, normally distributed, that's how we learned it before, or at least normally distributed, provided that either the histogram or the dot plot or the stem and leaf plot of a data is symmetric. And it's a bell shaped. This works when you draw histograms, dot plots, stem and leaf, and you look at it and you say, oh, it looks like bell shaped or symmetric. This means it's mostly or almost normally distributed. This idea or this procedure or strategy works only for large set of data when you have large population. But for small population, like a small sample, that does not work out. So it doesn't work out for small data. So this means we need some additional methods for assessing normality for the random variable x. And to do so, let me introduce what we call a normal score. It's basically the expected z-score. Is the expected z-score of the data value, assuming that the distribution of the random variable is normal. And then what is the normal? A normal probability plot. It's like a scatter plot. Seriously, it's a graph that plots observed, is a plot or a graph that plots observed data versus normal scores. Okay, normal scores. So this means it's gonna be like an XY plot where x is the original data that will be given to us, and usually like small amount, maybe 12, 16, around that number, original data, and y is its corresponding z-score. Its corresponding z-score. And then what we need to do is, so they will give us a small set of data. We are going to use a table. It's called table 3 here, and I'll show you that table, to find the corresponding z-score for each given x value. And then this way you create a list of points. That list of points, we are going to use a calculator or Excel or any other software you like to use to plot the points. And then we're gonna look at the graph, like when we connect the points, how the graph is gonna look like. Then what we're gonna do, let's watch. So to assess normality of the variable using sample data, construct a normal probability plot, which is a scatter plot, has points, plot them. If the plot is roughly linear, so it's about linear, then we can assume it's approximately normal. If it's not linear, then we cannot, so that fails the normality condition. So it's not normally, approximately normally distributed. This is important. And also, sometimes some books, they talk about the outlier. If there's more than 2 outliers, then that fails the normality as well. Like maybe some people say if it's 2, 1 on each side is okay, but I would say more than 1, that it fails the normality condition or the normal distributed condition. So that one is rarely used, or we're not going to use it that much. But if we look at an example here for this, so this is the data given to us. On the first, this is the given data, this one. Notice how the first thing you need to do, make sure it's arranged in ascending order. Make sure it's ascending order. If it's not, you must arrange in ascending order first. So this data, the first column, must be in ascending order. Now, after you do this, this is like data 1, data 2, 3, 4, 5, and so on and so forth. We have about how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have 12 of them. We have 12. So this is going to be used, the number is going to be used in the table. So what is the table? This is the table here. Now these tables, I put it here on purpose to have all the tables for all the formulas in the book. So this goes chapter by chapter, like starting from chapter 3, 4, 5 on, you will have all the formulas. And then after the formulas, we have tables as well. As you can see, the tables here. We need to go to table 3. Okay, so we are gonna work with table 3. It's called normal scores. So n here is 12. N is the number of selected data that we have. N is 12 data sets. So we are going to N12. This is 12. So data 1, whatever the data value was, corresponds to the first one. Next one, next one, next one, all the way down. You can go 12 of them. And notice, remember I said they give us 12 of them. So the negative 1.64 goes in the next column of the table, like the given table. Then negative 1.11, negative 0.79, negative 0.53, negative 0.31. So that goes into the table here. See, notice negative 1.64, negative 1.11, negative 0.79. So all these values, they came from the table. The question is, the table shows only up to 12 values. Because the author on purpose put only like a small samples. They don't want to put like so many values, because that's the idea, that we are working with really small values. We're not working with large values. Otherwise, normality is not needed here. We can use histograms or dot plot or any other tool. So what we need to do here is, the question is, if you're doing work on my lab and then they give like 16 values, they have the tables there. So you click on the icon and it shows you, or the link, and it shows you the other tables. I think they have up to 22 even, not just 12 or 16. So you can see the data values there. You just have to write them down, and then we're gonna see what we do with this. So now this is the kind of X value, and these are the Y values. So the first point has 7.8 comma negative 1.64, and next one the same, next one the same. So we're gonna take these points and put them into the calculator. We're gonna put them to the calculator. And why do we need to put them to the calculator? We're gonna graph this. We are going to construct the normal probability plot now. And then if the plot, which you're gonna see here, this is the plot. If the plot looks almost as we said here, if it's roughly linear, then normality is okay. If not, then it's not. So let's see what we're gonna do with this. We are going to go to 7.8. So we're gonna go, how are we gonna go with this? We're gonna go y equals first. First stat, and hit the enter key. If you have any data stored like this, you can clear it by using the arrows. You go up and click clear, not delete, otherwise you're gonna delete the whole list. You click clear and enter, it will clear everything. So what I did here, I entered the data already for us. So how do you enter it? You go to the first one, put 7.8. So just type 7.8, hit the enter key. Next, 9.7, hit the enter key. 10.6, hit the enter key. And then after you finish, you move on to the next list. So the first list contains all the X values. The second list contains all the Y values, the corresponding Y values. And then what do we do next? We are going to go second and Y equals, which is stat plot. And then we go hit the enter key. Now make sure this is on, not off. And then you scroll down using the arrows, and then you decide which one you want to plot. Okay, so I'm gonna show you more than one, not just one. So I'm gonna click on the first one, hit the, of course you're gonna test here, see in the data values, I put them in list 1, and the data access was in this list here. And then I'm gonna hit the graph, and then it's gonna graph it for me. Now the graph might look different than normal, because usually the graphs, they go like this, and then the points you're gonna see, like they go, let's say like that. So you can just ignore that line in the middle and assume it's in the bottom of the calculator. So just move that middle line down. And now if you look at this, one other thing you can do, go back to this and then hit the enter key. If you go down to the last one here and hit the enter key to select it and then graph, it will give us this one. If you go back, let's go back. I want to show you another thing. Again, down and then hit the enter key to select that one, the first one, and let's graph it. It's giving the same. One of them should connect. I thought the last, oh, the middle one maybe here. One of them should connect. Yes, this one. Notice how when the points are connected, it's not roughly linear, right? You can tell it's not linear. So this is not approximately normally distributed. This data, this given data is not approximately normally distributed. The other thing I want to show you here is how you plot, and you do need this for histograms. So all you have to do, keep everything the same. Just go to the histogram and hit the enter key to select it, and then go graph, and then you will see it. Now, if in case you don't see the histograms, go to zoom, and then go down to number 9, I believe. Yes, zoom stat, hit the enter key. It will zoom fit it in here. Do you see how the data is not normal distributed? It's more like skewed to the right side. So that's why this is not normal distributed. If you look in down here, do you see the data? As I told you, like this line was in the middle, just shifted down, and the data, you can see it's not normally distributed. That's what this section is about. And why do we need to know normality? Because we do a lot of things assuming the data is normally distributed. And if it doesn't work, it's not normally distributed, we can't use the data. We can't use normality to either analyze data or apply some conditions here and there for it. And that's why, so what this tells us, for example, this data tells us that this sample it didn't come from a normal distributed population or data, and that's why we can't use normality conditions or anything is being applied to normality.